All right. In this problem, very similar to the surface or to the arc length, we're going to look for the surface area of a particular function generated about the x-axis generating this y equal to the square root of 1 plus x from 1 to 5 on the x-axis. So we're gonna figure out what is the surface area of this graph. Okay. So the surface center, the surface inter, the surface integral is given by, if you can imagine, we talked about this in the derivation, but it's a it's a cylinder, right? So it's a strip that's being wrapped around. And so if you imagine if you imagine like coming along with scissors and snipping it, right? Those are really awesome scissors, I know, right? If you cut it right there, what would you have? Well, you'd have a cylinder where you see the 2 pi y, that is the 2 pi y would be like the height of the cylinder, and then or the circumference, if you will. So it's this value, okay? And then the distance along here, well, this is the result of the length there. Is where the tangent, or it's not the tangent, but it's where this is coming from. I'm trying to think of the word, the base, the base of this. It's an incremental amount because it's really small. So it's the surface, to generate the surface. It's the arc length of this. So the arc length of this segment, this infinitesimal segment, times the height of the this creates a cylinder, and that's what actually generates the surface area for what is. So I hope that makes a little bit of sense, or intuitively you can kind of make sense. So yeah, if this helps, here's the thing of tape. Imagine that this is the surface of the object, right? And so if I were to come along and peel off the tape all the way around one length, the one length of the tape, then the skin, aka this tape, okay, the height of it is the result of the function y, and the length of it, then this height, would be the circumference of this, which would be the 2 pi y. Okay, so that's how long it is. And then if you look at the base of it, okay, this is the arc length of the function, and the arc length will give us then the width of it, so that the entire area then would be the width of this times the height of the circumference of this cylinder. And so that's what is really behind the idea of the surface area. I don't know if that's helpful or not, but sometimes it's kind of helpful to kind of make sense of these functions and what they are and where they're coming from. Okay. Anyway, just like before, I'm going to focus in on here, just like I did with the um, so I keep looking at surface area and wanting to say that, just like I did with the arc length. So I'll take the derivative of this, square it, and then add 1 to it, and then plug all that stuff back into the integral to see what we can do with it. Okay. So dy dx is equal to, well, the derivative of this is going to be 1/2 using the power rule, 1 plus x, subtracting 1 from the exponent, and then taking the derivative of the inside. Since x is a linear term, its derivative is just 1. And so this is a pretty easy derivative with the chain rule here. So we get 1 over 2 square roots of 1 plus x. So pretty clean derivative there. Okay. And then now we're going to square that. Okay. So by square dy dx squared, I will get, okay, the 1 on top is just 1 squared, and I get 4 over 1 plus x, where the square root and the square are going to cancel out. Okay. And the 2, obviously 2 squared is 4. Okay. So this is this part, and now I'm going to add 1 to it to complete the inside of that. Okay, so 1 plus dy dx quantity squared is equal to 1 plus 1 over 4 1 plus x, which is common denominator is 4 plus, I should say 4 plus 1 plus x. Okay, so plus 1, all divided by 4, 1 plus x. Okay. Where I've taken the liberty of combining them under the same denominator here. If I distribute that 4 through, and then combine with this, you should see I have 4 plus 1. So this should give me 5 plus x over 4, 1 plus x. Okay, so that's everything underneath the square root here. And then I'll plug in the what y is equal to here with the 2 pi. And the limit, that's a b with a 2. The limit of integration for f will be from 1 to 5, since that's the area defined by this. Okay. So we have the surface area then is equal to the integral from 1 to 5. The 2 pi. The 2 pi is a constant with respect to the integration, so I can actually pull it out of the integrand, but I'll just leave it in there for now. Y was equal to 1 plus x, so 1/2. And then we have 5 plus x divided by 4, 1 plus x, 1/2. Now, dx, of course. Now, you may notice here that this and this, if I write it in a little bit more suggestive form, something really, really nice is going to happen. Likewise, 4 to the 1/2 power, in other words, the square root of 4 is 2. So pulling out the 2 and this term, I'm going to actually pull those all the way out just to kind of show where this is coming from. But I feel some really nice simplifications coming. So this is 5 plus x to 1/2 dx. And I'll write it over here to kind of emphasize this. So this is 4 to the 1/2, and then 1 plus x to the 1/2. Can't you see it yet? So this 1/2, 1 plus x to 1/2, and this one x to 1/2 are going to reduce to 1. And then this is the square root of 4, which is 2. So the 2 and the 2 are also going to reduce to 1, which greatly simplifies this integral to, the pi can come out now, 1 over 5. It looks like we have the square root of 5 plus x dx. Okay. And then the nice thing about that is that this can be a simple u sub. So if we let u equal 5 plus x, du is equal to dx. And if I plug in the limits of integration here, I should see that I get u of 1 is equal to 5 plus 1, which is 6. And u of 5 is equal to 5 plus 5, which is 10. Okay. But on to back sub in, so I get pi, the integral from 6 to 10 of u to the 1/2 du. Let's keep going down. Okay, adding 1 to the exponent and then dividing by it. So this is 1/2 of 3/2, so 2/3. And then you get u to the 3/2 evaluated from 6 to 10. Okay, and then just plugging in, you get 2 pi over 3, 10 to the 3/2 minus 6 to the 3/2. And there is definitely some further simplifications that we could do. However, for the sake of sanity, we'll leave it there. I hope that was helpful, and I'll see you in the